All right, this video is for the final review for college algebra. This is the fall semester of 2024. Okay. Here we go. Number one, what do we got?
Use stacking to solve the polynomial equation. Check by substitution or by using a graphing utility and identifying x-intercept.
Okay, so we're going to solve the polynomial. Okay, so what's the polynomial?
2x to the fourth power minus 50x squared equals 0.
Okay, so let's Desmos this and look at it. Okay, so 2x to the fourth minus 50x squared. So graph-wise, here's what we look like. We're opening up. It's like a W. We're crossing at -5, 0. We're bumping at 0, 0, but it is going through that point. And then we're bumping again at 5, 0. So do you have to pick the graph?
No, it just wants you to find the solution set.
Find the solution set?
Just where it crosses.
Just where it crosses those ordered pairs? Is that all at once?
It just wants the x values.
The x values?
Yeah.
So x equals -5, x equals 0, x equals 5.
You would just put -5, 0, 5.
Yeah.
Oh, okay.
Commas.
With commas. Okay. And that's all that one wants?
Yeah. And then the next one's the same.
Because that one can be factored. Which is weird why we would graph that one, because that's an easy one to factor. All right, what's number 2?
Same thing, but it wants you to solve the equation by factoring.
Okay, so this same equation?
No.
Okay.
X squared equals 3x plus 18.
Okay, so before we can factor, all the pieces got to go on the same side. So x squared minus 3x minus 18 equals 0. If we can factor it, if it asks you to do it by factoring, do it by factoring. That means it's factorable. You don't have to use quadratic equation or quadratic formula on this one. So 18, I could do 3 times 6.
Yeah.
And then one has to be negative, so -6. So how I'm picking those numbers, -6 times 3 gives me a -18. -6 plus 3 gives me a -3. So they have to multiply to make the constant. They have to add to make the b value. And so those are your factors, which means x equals 6 and x equals -3. This will probably give you a good idea of what's going to be on the final. This thing is like all kinds of crookedy. There we go. All right. Number 3.
The following rational equation has denominators that contain variables. For this equation, write the values or values of the variable that will make the denominator 0.
Okay.
These are the restrictions on the variable, and then the equation is x minus 3 over 4x plus 1. Plus 1's on the side.
Oh, okay. X minus 3 over 4x, and then minus 1 like this,
Plus 1.
plus 1. And it just wants to know what x cannot equal.
And then it says equals x plus 2 over x.
X plus 2 over x. Okay, so right off the bat, x cannot equal 0. And then you would set this piece equal to 0, but if you set 4x equal to 0, you're going to get the same thing. X cannot equal 0. If it's like addition or subtraction, if it's like 4 plus x, that's when it changes.
And part 2 says, keep the restrictions in mind, solve the equation.
Solve the equation. Okay. So first thing I want to do is I want to get rid of denominators, or I want to make everything have the same denominator. So common denominator, 1 is just over 1. So the common denominator between 4x, 1, and x is 4x. I can turn all the other denominators into 4x. So for the 1, I would do 1 over 1 times 4x over 4x. Gives me 4x over 4x. And then to turn an x into a 4x, I'd multiply by 4. So x plus 2 over x, multiply it by 4 over 4. 4x plus 8, and that's 4x over 4x. So now my equation is x minus 3 over 4x plus 4x over 4x equals 4x plus 8 over 4x. Fractions that have the same denominator can be written all in one piece. And then if the denominators are the same, I can set the numerators equal to each other. And then we start moving pieces. So x and 4x give me 5x minus 3, equals 4x plus 8. I always move the smaller x. I don't like messing with negative coefficients, so I just always move the smaller x. X minus 3 equals 8, and then I add 3 to both sides. X equals 11. I will double check that. Or are we still working on 3? Do I need to slow down? Uh-huh. All right. Number 4. What do we got?
Mine's 9x over x plus 1.
Okay.
And then to the side equals 3.
Just like that?
Yes, sir. Minus 9 over x plus 1.
Like that?
Yes, sir.
So common denominator here is x plus 1. So 9x over x plus 1 equals, if I multiply this, I would get 3x plus 3 over x plus 1 minus 9 over x plus 1.
So it's like, so the a is what are the values or values of the everything that makes the
Oh,
denominator 0.
x cannot equal 0. X cannot equal negative 1. Sorry, thank you. X cannot equal negative 1. Yeah, whatever would make the bottom, you can't have a 0 on the bottom of a fraction. Okay, so we've got common denominators, so now we can just set the numerators equal. Combine like terms. And then solve. So subtract 3x from both sides. And this one, x equals negative 1. But that's the can't be. So that would have no solutions. Is that an option?
Yeah.
All right, number 5. Anybody?
Alright, square root of 5x plus 4
Okay.
equals x minus 4.
Just solve it.
What's the solution side?
Okay. So I'm going to square this side so I can get rid of the square root, which means I got to square this side. So this would be 5x plus 4. This side, so remember x minus 4 squared is x minus 4 times x minus 4. Don't just do x squared minus 16. Be really careful with those. So this would be x squared minus 8x plus 16. And then move all the pieces together. X squared is already positive, so I'm going to move everything to that side. Eight, 13, 12 plus 12. Should be able to factor this one, because negative 1 times a negative 12 gives me a negative 12. Negative 1 plus a negative 12 gives me a negative 13. So x minus 1, x minus 12. So x equals 1, and x equals 12.
I said it was wrong.
Ugh. Okay. Because it doesn't make the solution true, because the square root of 9 is 3. And 3 does not equal negative 3. So that's, you have to check your solution. So the only solution there is 12. You have to make sure it makes it true. I don't know that I agree with that. All right, number 6.
Okay. X minus the square root of 2x minus 6.
Okay, 2x minus 6 under the radical?
Yes,
Okay. Okay.
Equals 7.
Equals 7. Okay, I want to get everything away from the radical. So actually what I'm going to do on this one, I'm actually going to move the radical, because I want it to be positive. So I would do x minus 7 equals the square root of 2x plus 6. Ooh, minus, right? 2x minus 6. 2x minus 6 is the original?
Yes.
Okay. Then I can square root both sides, or just square both sides, sorry. So I would have x squared minus 14x plus 49 equals 2x minus 6. X squared is already positive, so I'm going to subtract 2x from both sides, add 6 to both sides. X squared minus 16x plus 54. No. 55? 55? So this I could do 11 times 5 gives me 55. Negative 11 plus a negative 5 gives me a negative 16. So my factors would be x minus 11, x minus 5. So x equals 11, x equals 5. Check my solutions. So do an 11 first. 11 minus 2 times 11 minus 6 has to be equal to 7. So this is 22 minus 6 is the square root of 16 equals 7, which would be 11 minus 4 equals 7. That's true. So that one works. 11 should work. I will double check it. And then 5 minus the square root of 2 times 5 minus 6 equals 7. 10 minus 6 is a 4, which would be 5 minus 2 equals 7. That one I don't think is correct. But let me double check. Okay. Yeah, for the same reason. Again, my brain goes, oh yeah, the square root of 4 could be a negative 2, which would make it 5 minus a negative 2, which would make it 5 plus 2. But it treat it like a positive when you square root those. Shelby, you think we can do one more?
Yeah, why not?
Okay. All right. 7.
Find the domain of the function.
Domain.
X equals 18 over x squared minus 4x minus 45.
Okay. So what it boils down to are what values of x can you not use? What values of x, if you plug in there, would give you a 0? The solutions are going to give you a 0. So if you factor this, what, 9 and 5, x minus 9, x plus 5, that means x equals 9 and x equals a negative 5 would make this bottom 0, which means we couldn't have those values. So just because you have to be able to show your work, I would say, and I check it with Desmos. Nothing says that you can't check it with Desmos. You just have to be able to show your work with it. So negative infinity to negative 5, and then a union 9 to positive infinity. And so if I check it on Desmos, let's see, 18 over x squared minus 4x minus 45. And so you can see I can use all the other x's except negative 5 and except positive 9. So again, it's a way that you can check. The reason that I know that it's less than is I can go all the way up to that number, but I cannot use that number. I cannot use 9 as a value because it would make it 0. A little scotch less, a little scotch more, everything would be good. Is that how it wants the answer right there?
It said it was wrong.
Crack!
It says type your answer in interval notation.
That's just...
Brackets.
Nope, I missed this middle part.
Oh.
There should be from 5 to 9. I missed a whole interval.
Oh.
Because I can use anything between 5 and 9 as well. I just can't use 5 and 9. So it should be, do you want me to double check it before you put it in again? Okay. Okay, good deal. All right, we'll pick this back up tomorrow, get through as much as we can. All right, we're finishing up the final review. So, what are we on, 8?
Yes, ma'am.
All right, what do we got?
It's still 8.
Okay.
Find the domain of the function.
Okay.
And then it's 4 over x minus 11, and then plus 7 over x plus 4.
Okay. Got to have a common denominator. So we're just going to cross multiply here. So I'm going to do 4 times x plus 12, and then this bottom is going to be x minus 11, x plus 12. And then this one, I'm going to do 7 times x minus 11. And this would be x minus 11, x plus 12. So, if we don't want zeros, x can't equal 11. X cannot equal negative 12. So domain should be from negative infinity to negative 12, union negative 12 to 11. Wait, did I miss something?
Oh, no, yeah.
Okay, and then 11 to infinity. That's what it should be.
Yeah.
It is. Yeah, so it's finding whatever the bottom can equal. That's pretty much it. And so, like I've always taught kids this, to do this, not to expand it out, because they're already in factors, they're already in factored form, so it's easy to find your zeros. All right, number 9.
Negative 9x squared over x minus 4
and then x plus 2, all under the same fraction.
Like this.
Yeah.
So x can equal negative 2, x can equal 4. Domain again, is that what it's wanting?
Yep.
Union negative 2 to 4, union 4 to infinity. Those aren't too bad. All right, 10.
X plus 2 over x squared minus 4.
Okay. This one we got to factor. So I think that's the difference of two squares. When you do a lot of math, things will pop out at you. A lot of times kids go, oh, I can't factor that. Anytime you have one like this, and it's minus, and then this number is a perfect square, you can factor it like this. And so if you multiply this back out, x times x is x squared, x times negative 2 is negative 2x, 2 times x is positive 2x. So those two things cancel each other out, and then 2 times negative 2 is negative 4. Your eyes just pick up on it and they catch it. At y'all's level, you're just not that. You don't do it enough, you don't see it enough to catch those. So be really careful if you see something like that. So here, x cannot equal negative 2, x cannot equal 2. So negative infinity to negative 2, union, negative 2 to 2, union, 2 to infinity. Okay, somebody needs to take the candy corn away from me.
Candy corn. You shouldn't even pick it up in the first place.
I'm on like my second bag. There's like enough sugar in there to kill a small nation. Let's top it off with a cherry coke. Whoa.
I'm not a candy corn fan.
Huh?
I do not like
Oh, love me so. I love Peeps.
I like Peeps.
Now I will make myself sick on Peeps every year.
Oh, I cannot stand peeps. I can only eat them at Easter though. Like,
I'll eat them till I puke and then I'm done for the year. All right. 11.
Says find the following functions for f of x equal x plus 3 and g of x equals 2x plus 4.
Okay.
And then, like, the first one says f times g of x. Or-
So like F, like this.
It's like in one parentheses f times g, and then separate parentheses x.
Oh, so it's like this.
Yeah.
I always do these backwards. I think when it's written this way, you put G into the F function. So you would take this X value here and swap it out for whatever G is. So the X now becomes 2X plus 4 and then plus 3. It's substitution, so it's taking this whole thing and subbing it in for this X. And then if you simplify this, you get 2X plus 7. I think that's right. I always do them backwards.
Okay, yeah, that was it.
Okay. Does it want you to do the opposite?
No, but now it said, g times f.
So then this way,
Yeah,
but with these same two functions?
yeah.
So then we just take the F function and plug it into G's X. So then here we get 2X plus 6 plus 4.
2x.
Mm-hmm.
And then it has f times g and then to 0.
So, like this, and then a 0.
Yeah.
So that means we're going to take this function and we're going to plug a 0 in for the x. which would just be a 7.
And then it just has it reversed.
So then
G times N.
G of F. And so that would be 2 times 0 plus 10 would just give me a 10. Composition of functions. Okay, not too bad.
Hang on, Hugh, is all that
Yeah, yeah, sorry, sorry.
I'm sorry.
Nope, you tell me if I go too fast. So, number 12.
For f of x equals 2x minus 5.
Okay.
And g of x equals x squared minus 2.
Okay.
And then it wants parentheses f and then that like circle thing.
F of G
F of g.
of X.
Yeah.
Okay, so we take the G, we stick it into the X of the F. So 2 times x squared minus 2 minus 5, which would be 2x squared minus 4 minus 5, which would be 2x squared minus 9. I'm assuming that it's asking the exact same questions, so I'm just going to kind of work through.
Hang on. They're a little bit different. The next one is the same, but instead of 0 for the last two, it's -1.
Okay, so G of F, take the F function, plug it into the G. So this is where it's not super complex. You just got to remember your rules. So remember, squaring this is 2x minus 5 times 2x minus 5. You do FOIL on it. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x is negative 10x. Negative 5 is a positive 25. So this would be 4x squared minus 20x plus 25 minus 2, which would be 4x squared minus 20x plus 23. And so F of G, and you said it was a negative 1?
Yes, ma'am.
Okay, so I would just plug a negative 1 in for that x. 2 times negative 1 squared minus 9. Remember, when you square a negative, it makes it positive, so 2 times 1 is 2, minus 9 is a negative 7. And then if we plug 1 in there, so 4 times negative 1 squared minus 20 times negative 1 plus 23. So negative 1 squared is a positive 1. 4 times 1 is 4. Negative 20 times a negative 1 is a positive 20. Plus 23 is 47.
Really dope. I sent it to like 7 different people.
All right, 13.
The function f of x equals x cubed minus 11 is 1 to 1. Find an equation for f to the negative 1 power, the inverse function.
So find the inverse. Okay, so if we change this to a y, and then we swap the x and the y. So this would be x equals y cubed minus 11. Name of the game is to get y by itself. So we would add 11 to both sides, so we would have x plus 11 equals y cubed. And then to get rid of the cube root, or to get rid of the cubed, you cube root the other side. And so this would be the inverse, this piece. I should have added 11 to both sides. Does that fix it?
Yeah.
Okay. Sorry.
No, it's okay. There's a part B.
Okay.
Verify that the equation is correct. So once you check it, I guess.
Check it like with a value. Okay, so if we do f of f to the negative 1 of x, like that, we're going to take this and we're going to plug it back into our original. We're going to plug it back in there for the x. So we would have the cube of x plus 11, and then that's cubed, and then minus 11. So this cube cancels out the cube root, and we get x plus 11 minus 11, which is equal to x. If you do the opposite, we take this and we plug it in. We plug it in here. So the cube root, and then x is now x cubed minus 11 plus 11. These cancel out, and we have the cube root of x cubed, and so the cube root cancels out the cube and just leaves us with an x. That's how you test your inverse. It should cancel itself down 2x. $14.
Same type of question. F of x equals x plus 5 in parentheses, and then it's cubed.
Like this?
Yeah.
Okay.
So let's find the equation for f to the negative 1 power
Okay.
of x.
So y equals x plus 5 cubed. Switch the x and the y. So on this one, we have to get rid of the cube first. So we would cube x, and that's going to equal, or cube root x, y plus 5. And if we subtract 5 from both sides, we'd have the cube root of x, and then minus 5 would be outside that cube root. And so that would be the inverse. And so if we test it, so f of its inverse would be, I'm going to use brackets, cube of x minus 5 plus 5, and then cubed. This cancels this, and then the cube cancels that, so that one equals x. And then if we do test the inverse, we would have the cube root of x plus 5 cubed minus 5. Cube root cancels that, and we'd be left with x plus 5 minus 5, which just equals an x. So yeah, it checks. 15.
Solve the following exponential equation.
Okay.
Express the solution set in terms of natural logs or multiples. And it's 2e to the power of 7x
2e to the power of 7x
equals 398.
398.
And it wants the solution set expressed in terms of logs is
Okay.
That there would be like 2.
So first, divide both sides by 2.
still first and one.
Ah! Okay, and so we would get e to the 7x equals, I don't want to do that in my head, 199. Okay, if we take the natural log of both sides, Why does that not look right to my brain? The natural log and that e, what happens is it just becomes a 7x equals the natural log of 199. And then if we divide both sides by 7, that should be our x.
Uh, 2e to the power of 5x
Okay.
equals 1138.
1138. Okay.
So I divided everything
By 2.
by 2. Got 569. Natural log.
Okay, so natural
That's
log. Did you find it?
Yes, I used y'all's
Oh,
7x.
okay.
And then it wants the decimal of it.
The decimal is,
You can use a calculator.
yeah, so how many decimal places does it want?
2.
0.76. So in your calculator, in these, in the Inspires, you would just do, so I can do the fraction, I can do a natural log, 199 over whatever your value is. You can put all those in there. Okay, a 16?
It's the same thing, but it's e to the power of 1 minus 7x
1 minus 7x, okay.
equals 3233.
3233. Should work the same way. We should be able to natural log each side. Which would give us 1 minus 7x equals the natural log of 3233. We would subtract 1 from both sides, and then we would divide by a negative 7. Let me check it. Weirdo things that I've been taught or I've seen over the years is that you never put the negative on the bottom of a fraction. That may just be an individual quirk. And so what you would do is you could multiply like this whole thing by negative 1 over negative 1, which would change the sign of the top. It would make it negative natural log 3233 plus 1, and then you get a positive 7 on the bottom. That may just be like a personal quirk of one of the teachers I had. If it'll take this, then I say be good with it. Decimal as well.
It'd probably take both.
Yes,
yeah.
ma'am.
Negative 1.01.
Negative 1.01.
Mm-hmm. Okay, 17. Okay, go for it.
Use transformations of the absolute value function f of x equals the absolute value of x. To graph the function h of x equals the absolute value of x minus 3, and then outside is minus 1.
-1.
5.
Okay. If it's outside of it, you're going up and down. So you're going to go down 5. If it's doing it to the x, it's opposite land. So if it's x minus 3, it's going right 3. So to show you that on a graph, so absolute value of x, there's the original, and then absolute value of x minus 3, and then minus 5. So you can see the movement now.
So it wants like what transformations are needed in order to obtain, collect all that.
Okay, so it was translated 3 to the right, 3 units right, and 5 units down.
So
Is
would
that
be vertical and
vertical is a shift? Yeah, vertical shift, down shift of 5,
and then horizontal shift 2?
horizontal right shift of 3.
And then it wants you to graph it.
Okay, so again, absolute value parent function, the point is on the origin, so you're just moving the origin to 3, -5 pretty much. So that little sharp piece goes right
For
3.
the, would it be for the x absolute value? Is it just at like the original one? Is it at 2? Like, is that where it crosses?
The original
Yeah,
crosses the origin.
I know, but like, because it wants you to graph it. So like, what is another one?
Oh, another good point. So you got another good point at 5, 5. So if you go right 3, down 5, that's going to be 8, 0. It's going to cross the x-axis at 8, 0, and -2, 0. Does that help?
I just needed, because like I needed to know where it would go up. So
Okay.
like another one.
All right, 19. What do we got, Shelby? Oh, see, you're not even ready.
Sorry, I had to burp. Find the zeros for the given polynomial function and give the multiplicity for each zero.
Okay.
State whether the graph crosses the x-axis or touches the x-axis or turns around at each zero.
Okay.
F of x equals x cubed minus 32x squared plus 250x. Wait, 256x, sorry.
256x.
Sorry.
Is that right?
Yes.
Okay. First thing I would do is I would factor it. So I can factor an x out of everything. Okay. And then I can factor this. And so 256, what can we divide into that? 12? Nope. Let me do it this way. 256 divided by x. Control T. So we need two numbers that will add to make a -32. They're both going to have to be negative if this one's positive. 8 and 32 won't do it. 16 and 16?
Yep.
Okay. So that means our factors, or our zeros, are x equals 0 and x equals 16. X equals 0 has single multiplicity, or a multiplicity of 1. X equals 16 has a multiplicity
2.
of 2. So what that means on the graph.
So the zeros are 0, 2 zeros.
All right, so Shelby, at a multiplicity or at the 0,
It touches.
x equals 0, it crosses. Uh-huh. So it's going to go across there. And then, what are the other two options?
It touches the x-axis and turns around.
So I believe multiplicity of 2, they're calling a touch.
So yeah, it like combines lines though. So it says the graph touches the x-axis and turns around at x equals 60.
So again, we would call them, like when they would do that, it would cross, it would bump, which is what this one, we would call that a bump. And then multiplicity of 3, we would call a slide. It would slide along like the x-axis and go up the other direction. That's what we called them. I don't know that I like the touch and the all of that. Okay, so that's 19.
20 is the same. Lines
Okay.
f of x equals x cubed plus 7x squared minus 9x minus 60.
Okay, so this one I would factor by grouping.
63, sorry.
63 minus 63.
Yeah.
I would factor by grouping. So I do x cubed plus 7x squared, and then I do negative 9x minus 63. So here I can factor an x squared out of everything, and I'm left with x plus 7. So name of the game over here is to get an x plus 7.
So it would be -9.
So yeah, negative 9, yeah, factor out a negative 9. So my two factors would be x squared minus 9 and x plus 7. I'm not done yet though, because x squared minus 9, that's the difference of two squares. So remember, x squared minus 0x minus 9, that will factor into x plus 3, x minus 3. So when this is minus and then that last number is a perfect square. So those are your factors. X plus 3, x minus 3, x plus 7, which would be x equals negative 3, x equals positive 3, x equals negative 7. They all have a multiplicity of 1, so they're all just going to cross.
Solve the system of equations using matrices. Use the Gauss-Jordan elimination.
Okay. What do we got?
So you have x plus y plus z equals 4.
Okay.
X minus y minus z equals 2.
Okay.
And then x minus y plus z equals 8.
And it went to the Gauss-Jordan method.
Yeah.
I hate these. All right, I'm going to try to wing it and do this. All right, I'm going to do -1 times row 2. So everything else is going to stay the same. And then row 2 is just going to change their signs. And so that gets the 1 there that I need. To get the 0 here, I should be able to do now row 2 plus row 1. So row 1 is going to stay the same. -1 plus 1 is a 0. Nope, that's not going to work. So then let's do, oh, okay. And this is why I give up on these every time, because you can sit and you can fiddle with them for literally forever.
The entire test is
Yeah, so that's why I told you, you get one of those. Okay, so let's forget this. The first thing they did, huh? It's paused. Okay. They did row 2 minus row 1. which is going to give you a new row 2. So 1, 1, 1, 1, negative 1, 1, 4, and 8. So 1 minus 1 is 0. Negative 1 minus 1 is a negative 2. Negative 1 minus 1 is a negative 2. 2 minus 4 is a negative 2. Then they did row 3 minus row 1. So row 1 stays the same, row 2 stays the same, row 3. So 1 minus 1 is 0, negative 1 minus 1 is a negative 2, 1 minus 1 is a 0. See, that doesn't make any sense. 8 minus 4 is a 4. Why they'd get that 0 there? Okay. Then they did row 2 divided by 2. So row 1's going to stay the same. Row 3 is going to stay the same. 0 divided by 2 is 0. Negative 2 divided by 2, or is it by, oh, they divided by a negative 2. Negative 2 divided by negative 2 is a positive 1. Negative 2 divided by negative 2 is a positive 1. Negative 2 divided by negative 2 is a positive 1. Okay, then they did row 1 minus row 2, and that's to get the zeros in row 1. So 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. 4 minus 1 is 3. Then they did row 3 divided by 2. See, I've got a 1 there and I shouldn't. Before we do this, they did row 3 plus 2 times row 2. So row 3 and then 2 times row 2. And then if you add those, 0, 0, 2, and 6. That's your new row 3. Then they did row 3 divided by 2. So 0, 0, 1, 3, and then last step was row 2
I did it.
minus row 3. Did you get through it?
I did it. Now for the next one.
0, 1, 0, negative 2. So your solution should be 3, negative 2, 3.
So,
Yep. Another one like that?
um,
Okay.
X minus y plus z equals -5.
Okay. So 1, 1, 1, 1, negative 1, negative 1, 1, negative 1, 1. Okay. So let's get a 0 here first. If I do row 2 minus row 1, so row 1 is going to stay the same, row 3 is going to stay the same. 1 minus 1 is 0. Negative 1 minus 1 is a negative 2. Negative 1 minus 1 is a negative 2. 3 minus 3 is a 0. And then let's get a 0 here. So row 3 minus row 1. So row 1 stays the same. Row 2 stays the same. 1 minus 1 is 0. Negative 1 minus 1 is a negative 2. 1 minus 1 is a 0. And then negative 5 minus 3 is a negative 8. And then we can do row 2 divided by a negative 2. So 1, 1, 1, 0, 1, 1, 0, and then this row would stay the same. And then we want to get zeros there and there, so we could do row 1 minus row 2. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. 3 minus 0 is 3. Everything else stays the same. Then we could do row 3 plus 2 times row 2, 0, negative 2, 0, negative 8, 2 times this, 0, 2, 2, 0. So that's a 0, that's a 0, that's a 2, that's a negative 8. And then we could do row 3 divided by 2. So now we have 1, 0, 0, 3, 0, 1, 1, 0, 0, 1, negative 4. So now I just need a 0 here. So row 2 minus row 3. 1, 0, 0. 0, 1, 1 minus 1 is 0, 1, 3, 0, negative 4. So that should be your solution. Right here when I did row 2 minus row 3, I just put a 0 here. 0 minus a negative 4, that should be a positive 4. So it should be 3, 4, and then negative 4. And that's it on the review, right?
Yep.
Okay, sweet.